Okay, so we're gonna make a small little thing here in Unity. I hesitate to call it a game because basically we're just looking at a, a starting point for using Bolt rather than typing up our scripts in C# to control ultimately a game, but I'm a little hesitant to call this one a game. So I went ahead and started Unity here because there's no need to, and created a new project because there's no need to watch that in a video. Just open Unity, hit new, give it a name, place to store it, all that, and then wait while everything gets loaded in. So to start with, before we get to Bolt, let's put something together to work with. So my plan, at least on the rough draft of the tutorial here, is just have a character moving back and forth across some ground. So a character standing on a ground level, well, that's just some basic Unity physics engine stuff. So we can set that up before we get into Bolt. So I created a couple assets here. Um, Not very nice ones. Just very quickly, I drew the rough idea of a human and a block of ground for him to stand on. And I spent less time on that than it would take to download something. So the final draft of this video will have nice ones downloaded. But I want to go ahead and import those as something we can use. So over here in the assets folder, I'm going to create a new folder. So create a new folder, call it pieces, game pieces. Just some arbitrary name to put it in. And now inside that folder, I'm going to import new asset. And I put those in my delete folder, the temporary folder. So I'll go ahead and select both of them and import that. So now we have these two pieces that we can do stuff with. So bring in a character to use and bring in some ground for him to stand on. I'll zoom out a little. That'll work. Probably want to stretch that the whole way. Well, yeah, go ahead and stretch this out. So for the sprite render, I'm going to switch that to tiled and change the width to longer than that. So I just drew a quick image where it book matched. So the left side of one picture lines up with the right side of the other, just to fill out the ground for him to stand on, and then the character here, we'll want him to stand on the ground. And we want the rules of physics to apply to both of these. So both of them will need to be rigid bodies, and we'll go ahead and set a collider on them. So that way just let the physics engine detect a default collision and get the player standing on the ground. So with the player selected, we'll come over here, add component, a new physics 2D component, and it needs to be a rigid body so that the laws of physics apply to that game object. And we also want a box so that we can tell when it collides with another thing. So it's set to dynamic and gravity's pulling on it, so he'll fall down and stand on the ground. We'll also need a box collider, which is also under physics 2D, and a box collider, which we can see highlighted around him. That'll work. It's just for standing on the ground, so it looks like it's lined up with his feet. And the same thing with the ground here. We want the laws of physics to apply to it, so I'm going to select the ground object. Then over here, we need to make that a rigid body. And the ground's not going to be moving though. So we can just set that as a static rigid body. But we'll also need a collision box, a collider box, or some sort of outline. And it's a nice square shape, so just a box collider will work. Except that the default one is a little small. It's just covered one of the tiles. So if we click the edit collider, we can stretch that out to cover the whole platform. There we go. So that should apply the laws of physics so that the character falls down and stops falling when he hits the ground. So let's run that and check it. Yep. So there's a character playing on the ground, but now we need to control it, which previously was done a lot through C# scripting, but not everybody's familiar with code. So there is a no-code or low-code solution where we use our mouse to drag things around on the graphical user interface, the GUI, and just connect different things with the mouse images. So we're looking at things instead of typing up a bunch of text and risking tons of typos. And we let the computer type the code for us. So that's what Bolt is. It's been around for a while, but it has only recently become an official part of Unity. So it's a free asset that we can use in Unity. So let's set Bolt up in this project and look at how we can use a low-code solution to generate those C# scripts for us, even if we don't know how to code already. So to get Bolt into our project, we can go to the Asset Store. Under Window, there's an option for Asset Store. Or you can just use a browser and navigate there. I find it's a little easier just to do it from within Unity. And I'll go ahead and make that bigger so we can see all the buttons. And let's search for Bolt. My Wi-Fi seems to be running really slowly this evening. There it is. So obviously the first results on the asset store are going to be lightning bolts as assets we can use in our project. Probably a good one to download because those look really nice. But we want this, Bolt Visual Scripting, which is a free asset. It used to be very expensive. It's a very powerful one. Anything we can do in C#, we can also do. We can link together these little blocks, and Bolt will write the C# code for us. Generate it in the background, kind of. Which is really nice because humans have a tendency to make typos, but computers do not make typos. So I think the button says purchase, even though it's a free one. You click the button that says purchase, there's no charge or anything, and then you'll get this button to import it into a project. So if we import, it's going to start downloading it and get that into the project. So you can close this window. Where'd my close button go for this window? There it is. Make that smaller, and then, well, I'll just leave that open because I need to take some pictures for the written version. But once we have this, you'll just click import. Select which versions you want. For starting out here, the defaults are going to work for pretty much everything. So you hit import and wait until the wizard comes up. There's a bunch of stuff, so I'm going to pause the video because there's no need to watch all the waiting part. Okay, so now that all that's been downloaded, there's a new folder in the assets called Install Bolt. So if we go in this, there's a couple executables here. We'll just select one of those, and that will open the importing wizard. And more waiting, so I'm going to pause the video again. Okay, so that took about 4 or 5 minutes to get going. So you'll just wait while all that stuff imports, and if you're watching the meters, there's a section in the middle where it seems like it's frozen, but I guess it hits big things or something. So there's a section where it looks like it's frozen, and then it finishes up real quick. But eventually it'll get to the Bolt setup wizard. And for the most part, the defaults are okay for starting out. There's one thing a choice we have to make. Do we want human naming or programmer naming? So if you've used C# before and are familiar with the way we would write the names in code, you probably better to go with programmer naming. Or if you're using Bolt as an introduction to learn C#, then programmer naming might be the case there. You can just, and then you'll see what they're going to look like when you take the next step to writing in C#. Or you can go with human naming. Either way would work. You can see here we have things like this. The human naming says transform and then spelled out nicely with spaces, get position. Whereas programmer naming just says transform.position and then it gives us a hint that that's the get function. So either one would work. They function exactly the same. It's just the labels look different. I'll go with human naming this time. And everything else, we can just accept the defaults, which is basically everything. In very large projects, and after you're a little familiar with what Bolt is doing, you can go ahead and select just the ones you're going to need. I'm going to go ahead and go with the defaults, bring everything in, and when you get to the end, hit generate, and more waiting. Okay, the wizard's finished installing everything, so we can check the manual, adjust any configurations, or go ahead and close the wizard. Now we need the windows to work within Bolt. So under Window, we'll have some new options here now. There are several. The two that I always like to include are going to be graph and variables. So obviously we're going to want access to our variables. We can set it up anywhere. Personally, I like to dock it over here under the inspector. Just in my mind, it seems like it belongs. Variables are connected to the inspector panel, so I like to put that there. And we'll be putting together our operations controls for the game with the graph window. So we'll definitely want that. And I usually like to dock that over here, which the asset store is still open, underneath where the scene is. So, like looking at the scene up here, dragging the mouse around to set up controls for this scene right underneath it, and with the variables right underneath the inspector panel. That's how I like to set that up. All of us think a little bit differently, so wherever makes the most sense, you're probably going to want to see at least those two panels, the variables and the graph. And a third one that may get used a lot is there's also an inspector that goes with the graph and has similar features that this inspector has to the game objects. But at least the graph and variables. And in case things get changed, I'm going to go ahead and save this layout so we can get back to it. So save layout, and I will call this Bolt 2 because I think I already have, well, maybe a few numbers. I'll call it Bolt 246 because I think I already have at least one layout called Bolt, probably more than one. And that way you can get back to this layout with the graph window docked underneath the scene and the variables docked underneath the inspector. Okay, so if you're familiar with using Unity, you've probably organized your control functions into C# scripts. With Bolt, we'll do the same thing, but we'll call them macros. So let's set up a new folder in Assets to keep all of those in. So I'm going to come over here and right-click. So under Assets, create a new folder and call it macros. So in here, I'm going to right click under create. We have these options for both, either a flow macro or a state macro. So we're going to look at a flow macro here. So that's going to flow from item to item. Versus a state, we could set up the states the game, the states of the game at any point in time. So to start off with, it flows more naturally for most people to think of the flow, how the game flows from one state to the next, rather than thinking of the state it needs to be in. So let's look at create a flow macro. And for this example here, I'm just going to have this character move back and forth on the screen. So to get this, so we want this character to move back and forth on the screen, so let's just give that a meaningful name. Move character. So now we have this graph, we can this macro that we can start putting our control functions together in. So now that we have our macro created, we're ready to set up our variables and control components. We'll talk about the terminology for them here in just a second when we get over to the graph window. Let's start with the variables. So if we go into this, make sure you're in it. Over in variables, well, we're going to move this character back and forth. So obviously we're going to need a variable to control his speed. So let's set that up to talk about this. So first off, we have to give it a name. So just select that and give it a name. So we'll call it speed, the character, how fast the character is going to move. Add that. And I'm going to what type of variable it is. So we have a name, and then the type of thing, I'm just going to set it as a floating point number. And for an initial value, I'll just put in 0.3. It's going to move a third of our unit every pulse of the clock, or pulse of the engine. Every time the game updates frame to frame, we will move 1/3 of a unit some direction or another. We'll set up the directions here in a moment, but that's all we need to do to set up variables. So instead of overriding one for the graph, we could refine it a little to a particular scene. It would behave the same, so just give it a name, choose what type of thing it is, and with both we have access to any type of variable in C# or the Unity engine libraries. So now that we have that, we can start working on our graph. So our main pieces, the things we connect to create the flow of the game, are going to be called units. And we bring those in using what's called the fuzzy finder. Just right click to get to it. If we just right click, we'll get the fuzzy finder so we can search for things. So there are two very important ones that we want to include. So first off is start. We want to make sure we have these in every one of our scripts. So we need some sort of start unit. And the start is things that run once. So this is like the initializing the character. The initializing everything for the character. All the stuff that will only run once. And along with that, we right click and add unit. We also want the update. So I'll put that in the fuzzy finder. And it's called fuzzy finder because it has some better search features. So there's some multiple types of updates. A late update. So a late update is the stuff that is the very last thing in the frame. So like it's a good idea to do your camera stuff on a late update. That way everything else is already moved as the camera adjuster. Or a fixed update is things that are going to happen at a steady rate no matter what else is going on in the engine. But for us, let's just use a regular update. And this is what happens at every frame of the game. Every time the engine moves from one state to the next, everything that's going to happen. So the start method is the initialize things, and the update method is what happens each frame of the game. And these are called units. our main box, we bring in a bunch of units. That's how the main idea of how Bolt is going to work. We set up our units and these little connecting points off to the side. These are called nodes. So we bring in a unit and then we'll click on a node and drag it over to connect each unit in sequence. Well, it looks like we might need a little more room to work with here. So we can use our mouse wheel to scroll in and out, and I'll scroll out and I'll put my cursor here and scroll in, and notice that where the cursor is affects how it scrolls in and out, or if you click on the mouse wheel, you can drag things around. That's kind of the two main controls for setting things up. So for us, we just want our character to move back and forth. But first, we should probably do a test just to see if we can get him moving. So first off, let's just move to the right. And we'll just let him fall off the edge for the first test. Make sure he can move. So every game object has something called a transform. That's a property that keeps track of its location, its orientation, its rotation. All of that information is stored in what's called a transform. So to make the character move, we're going to change the transform at every frame of the game. So we'll do that in the update event. So we need to click on the node and just drag over. And when we drag over, it'll automatically bring up the fuzzy finder. So we know we're changing where the character is in the scene. So we'll look for the transform for this object. And when we type that in, we'll get a number of options here. So we can change the rotation, what it's looking at. And here's the one we want, translate. So there's a few options. We'll just take the basic translate. We're going to change either the X, Y, or Z component. So, well, we're in the 2D version, so we're going to change the X or Y version. And we'll just change the X. It's just like graphing in math class. We have our X-axis going horizontally and our Y-axis going vertically. So we'll change the X and Y, the X value to move back and forth. And notice down here at the bottom of the fuzzy finder, we get descriptions of what it's doing. So it moves the transform by X along the X-axis, Y along the Y-axis, and yeah, we get a description of what each one of these units will do. So that's the unit we want, and I'll shuffle that around, kind of zoom in on it. So this first option is, what does it apply to? So in our case, we're going to link this macro that we're creating to our character object, so it's going to refer to itself. So that'd be fine. And then we want to change the X object, the X property of this. So we could just type a number in here, but we already have a variable stored over here that indicates the speed we want that number to go at. So to connect to that variable, we can grab this node over here next to the X attribute and just drag it over. And again, it'll bring up the fuzzy finder with the most likely options. So if we're changing it, it expects either a literal to go in or us to do some math. If we scroll down a little, somewhere down here, or it expects us to feed in a variable we already have saved. So that's the one we want here. So we'll click on variables, and then over here, we stored that as a graph variable under the graph tab. So we'll go to the graph, and we have getters and setters for general graph variables, or we have a getter and setter for that variable we already created. So we just want to get the speed variable. I'll zoom out a little, kind of shuffle this around so that things are organized nicely and we can keep track of what's going on. And it's not much, but this is enough to move the character to the right. So every frame of the game in the update unit we're going to adjust the X attribute of the transform translate property by whatever's stored in the variable, which is currently 0.3. So that'll be enough to test and see if our character is going to move. But we need to do one more thing. We need to link this macro to the character. So to form that connection, we'll come over here and select the character, or you could select it from the hierarchy chart. Sometimes that's a little easier when there's lots of stuff in the scene. But we'll select the character, and then over in our inspector, we see all the information about the character. Its current transform, so we see where its starting position is. So this is the value we'll be changing. And information about the sprite on it. We added a rigid body and box collider, so it follows the laws of physics as far as the Unity physics engine knows here. But we need a way to connect this flow graph, the macro we created, to the character. So we'll add a component and search for flow machine. And you can see some of our options here. The source for the is going to be a macro. And the macro itself, we need to choose which macro to put in. And we want to link it to that macro we just created. So we'll drag that over. So that connects this, adjust the translate values of the transform, the X attribute by 0.3 at every frame of the game is now linked to our character. So if we run this for a quick test, we should see the character start moving to the right. And that's all he's going to do, so he's going to fall off the ground fairly quickly there. But once everything's ready, there he goes. You can see our character just flows off to the right, moves by a third of one of our units every frame of the game. And down here, I think my screencast software is kind of slowing this down a little, but we can see there's a graphical indication of the flow of what's going on. So that's something that makes low-code solutions very nice for humans. We have a visual representation. We can see visually what's happening. That, and then that really nice attribute of them is the computer's writing the code, so computers never make typos, whereas humans are very, very prone to making typos. So those two things are really nice, especially this visual representation. So when things go wrong, we have these pictures we can look at to help determine where it's going wrong at. But that's the basic idea of Bold. So I'll go ahead and stop the game. So our character moves. So I guess we probably want a little bit of control. And adding that in, we'll kind of go over selection structures, how we make choices. Are we pushing the move left key or the move right key to move the character back and forth? So let's adjust this and get that control in there to see the selection structures, and that should provide a good starting base for using Bolt with Unity. Okay, so now that we know this moves our character, let's update that so that it moves when we push. It moves to the right when we push, say, the D key. That's the standard control for that. And just on a side note, in between scenes, I checked, and it wasn't the screencast software slowing it down. I'm doing the written version on Google Docs, and I have that open in Chrome with several other tabs. And Chrome is what was slowing everything down there. I should have known that beforehand. Chrome likes memory. So we can move this out of the way. So first off, we can just grab them and slide them over here out of the way. And then we'll do this at a particular point instead of every time. So we can get rid of this arrow by hovering over it, and when it turns yellow, just right click on it to delete that connection. But we know this works to move our character to the right. So it might be useful to organize it a little. And obviously, the more we do with these macros, the more that some nice organization and labeling comes in handy. So to group some things, if you hold down the Control key and drag a box around it, so Control plus dragging a box creates a group. And then we can just give that group a name. So let's call this Move Right. So the little bits of organization really come in useful as the macros get larger. So now we're ready to, so instead of going right all the time, we'll set up some controls for whether we want to move left or right. So I'll just do a key press for the A key and the D key, our standard left and right, and then we'll be able to push those and move our character back and forth. And that'll also involve a branch making choices, the equivalent of an if structure in our regular scripting code. And that will cover a lot of the basics for this tutorial, which from filming the scenes is starting to feel like it's going on for quite a while. So in later drafts, I might have to talk quicker or abbreviate some things. Well, this is the rough draft. This is getting ideas together, but hopefully this is going to be enough to get a good start into using Bolt. Because as was stated earlier, anything that we can do in C# scripts, we can do in Bolt. So Bolt being officially part of Unity is new. So a lot of the reference material is going to say things about scripts, but anything that is done in a script that you find in other reference material, you can just search through the fuzzy finder and find those same names as Bolt units and kind of do a visual connection rather than that typing connection, and avoid chances for typos or watch those little arrows flowing down the lines to pinpoint problems when you get to debugging. All right, so now let's put in these controls. So like I said just a second ago, it's kind of starting to feel like this example is getting rather long. This tutorial is starting to get long. So I'm just going to do the move right one, and after I render this down and check everything, that's the whole point of making a rough draft. The next draft will hopefully have move left and right, but we'd see how. But moving left will be an exact, virtually just a copy of the moving right. All we'll do is take the negative of the value so that it goes the other direction, speeds the other direction, and yeah, then a different key press. So let's look at the key press. We need a selection. We need to know which key we're pressing. So the equivalent of an if structure in our scripts, so making selections, that's going to be a branch here in a branch unit in Bolt, which is under Control. So we can just search for it, but it's a very common one. So under Control, the top option is branch. So we're going to go one way or the other. So every time the frame updates, we're going to make a decision of whether or not to move the character to the right. And just like an if structure, we'll have do something if it's true or do something if it's false. So in our case, we'll just do something if it's true. So every update of the frame in the game, so every time the frame up changes, we're going to check something. We're going to check a condition, and if that condition is met, then we'll move to the right. But if it's not, then we just won't move to the right. So to set up the condition, notice how instead of well, like these little arrows indicate a flow. Things are flowing from one unit to the next. Whereas here where we set the variable, bringing in a value, we had a blue dot. But over here in our branch unit, we have this purple dot, or whatever color that is. I'm going to say purple. That's what it looks like on this screen. But if I put it on my other monitor, it looks more pink. But whatever color we call that, we need to set something up for that. So if we bring over what it in, and that color indicates a Boolean. So some sort of Boolean is coming in. Well, we want it to come from an input, a keyboard input in particular. So we'll stick that in the fuzzy finder. And right down here we have get key, either by key or by name. Have the different buttons we could press. I'm just going to go with the simple get key. So we'll select that. And then our condition is basically checking whether this key is being pressed or not. So if the key we select is being pressed, this will output a true. And if it's not, this will output a false. We'll see that when we run it here in a moment. So there's a long list of keys. Right? We have a pretty big keyboard. So I'm going to use the down arrow on the keyboard to scroll through it quicker. And to move to the right is typically our D key. So I'm going to select the D. So now if the D key is being pressed, this will output a true, which means we will follow this branch. If the D key is not being pressed, this outputs false, which will follow this branch, which doesn't do anything. It just says, okay, we're finished with the update. So that should provide us something that will run. So go ahead and hit run the game. And we're still linked and everything. Once we link it, we don't have to relink it every time. So our character came down, and unlike the last time, it didn't start moving on its own. And we can see down here in the flow under 8, it comes over to the branch, but our input unit is outputting a false. So it's going down this branch, which just means we're done with the update. Nothing happens here. If I come over here and press the D key on the keyboard now, well, we can see now it's outputting true. So we take this branch, which moves to our move right one. And when I stop pressing the key, that now outputs false, and the character no longer moves to the right. Or if I push the D key again, it's going to keep moving right. So we can see that works. And these videos are starting to feel like it's taking a while. I'm doing screenshots so you can see down in the corner how much time has passed since I started filming this. It's a rough draft, so I'll see how long it is because I'd really like to get the left and right in the example. But moving left is just a slight variance here. All we have to do to move left is select a different key, and we can do more than one branch here. We can come down here and set up a second branch. Well, yeah, I'm going to see how long this video is before I do that, but then we can set up more than one branch so that we can check different things different times. I'll undo that for now, go back to this one that works, and so we can set up more than one branch, and then all we would do is move the negative speed instead of the regular speed variable to go in the left. So that is almost identical to this, so I'm going to check how long the video is in the rough draft before including that, but hopefully that will be in the later versions. And hopefully that is enough to get you started on Bolt. So there's lots of reference material out there for Unity. Bolt being something official is new, but any place you see things mentioned in scripts on Unity references, you will be able to find those features in Bolt. Just use the fuzzy finder to search for things by the same name and kind of put your scripts together, and then you have the visual representation and the computer does not make typos like we do.